Finally start streaming because I forgot to in the other class. We're live from down. Where's the file?
What's that?
Oh, right, it crashed. That's what I was fixing. Where's my You will notice it says, oh, this is the wrong one. You'll notice it says part 2. I'm not explaining. No, I'm not explaining. And that's the one you're not allowed to know.
Compound? The
Jojo.
compound one?
Oh, right. I didn't realize.
Come. Ah!
One class.
There we go.
What is next?
We know you're used to Jojo.
At least you didn't do stuff in the forest. It's on the travel.
I just noticed you're not in proper dress.
It's because I had a Kidlet today.
Oh, Kidlet. That's one of the best ones.
It is fun.
You are fully excused almost forever.
What?
When, I won't say who, was very small. This program had a reader. Actually, at that time, it was, not at that time, a student at a teacher at Shawnigan was also doing it. Ms. Hedquist invented it and was doing it. And they came to our school and read to some of my children and made a little storybook. It was so cute. It was so awesome. Little kids getting stories. Kidlet's the best. Who's your person?
My buddy,
Yeah.
his name's Axel.
Axel?
Yeah.
Is Axel hit you yet?
Is it what?
Has he hit you yet?
Oh,
No. They had a problem with one of them. At least 2 kids apparently were trying to hit their buddy.
Really? With
Some of the little, they're nervous.
Some of them
They're
are
like little deer.
You know
I remember
Eric,
this one.
like Eric Ekmar?
Yeah.
His little guy like referred to Gune.
He prefers what?
To Gune. It was like
what's that?
He referred to
it was like brain rot.
Yeah, you're not supposed to say that word. That's an inappropriate word. Okay, I'm going to start physics. Jojo, can you put that away? Because you're not doing that. Pablo, do I need to confiscate the computer? You should have your notes out. That we're starting for physics. From chemistry, what is potential energy? Oh, you were gone. Did you not get one? I did.
The energy that could potentially
I'm guessing.
be released.
The word potential does have a sense of anticipation in it, but from chemistry, where did we say the energy was?
Stored.
Chemistry is
Stored.
stored where? Bonds. So it is stored energy in bonds. Bonds. James Bonds. Yes. Now in physics, we're not going to talk about bonds because this is, of course, a chemistry definition, and we're not going to do that because we're in easy chemistry, otherwise known as physics. So energy in physics
Oh.
This is probably the most dangerous thing I'll do all day. I checked if there are wheels on here. I see boys, well, not necessarily, people in Privet House get up on their chairs, like they're rolly office chairs to reach something up high. Like, boom, down, neck broken.
Oh.
It hasn't happened yet, but there's been a few concussions. I'm just waiting for that day. Don't get up on a rolling chair. This is locked, and I'm being very careful, and I'm the teacher. So if I die, it's not your fault. But if you die, it's my fault. So don't. However, you should be looking appropriately nervous because I really shouldn't be doing that. Ooh, I stepped from one to the other. Now, why is this dangerous? I could fall. I have the potential to fall. Nice connection. Why do I have more energy than I did before?
Because you're higher up.
Because I'm higher up. So in physics, the definition of potential energy refers to your height, often measured from sea level, but really it's just your height. We're above sea level because we can see the sea. But really, I'm only worried from here to the floor. So we call the floor 0 and calculate my height up. Also, I think the uniform, we should add a vest. Have you?
Yeah.
We should. We
Yes.
totally need to add a vest.
Yeah.
Because I only recently got this vest. I've only started wearing it for like 2 weeks. But really,
It'd be
like,
a great
like when I go like
alternative
this,
for the summer.
I'm just Mr. Neufeld, right? Like I teach and I have my house party. But when I go like this,
It'd be a great alternative for the summer because it gets hot in the blazer.
no,
I
the,
wish that
the
was
blazer
me.
with it. Because once you do this, I'm not just Mr. Neufeld, teacher of science. Now I'm Mr. Neufeld, member of the board. I feel like I could order anybody to do anything. Although that also comes from being over 6
Right.
feet tall. Okay, so stored energy in
How tall are you?
height 6'5".
I think this was 6'3".
And when I say 6'5", that was the last time I measured myself when I was 19 years old, and I'm going with that measurement for the rest of my life. They say you shrink if you get older, but if I don't measure it, it didn't happen. I should find my
I
notes.
can't remember if it was Miss Valencia or Wilbur who told me to call you 6'3".
Well, I don't put a lot of stock in 6'5". It just that's the last number I had. And I tried to measure myself a couple of times, but it turns out I don't use a tape measure really well, and so we usually get it wrong in both ways. So, okay. Potential. So it's stored energy in height or position. What does potential mean? As in potential energy? Yes.
Something that could happen.
Could happen.
As long as another event takes place.
Right. Could happen is the English definition. Well, it is now. You could change it, but right now. In physics, that's not really what it means, but they chose that word deliberately because they do mean it could happen, but they mean energy that, and we use could again, could be converted to work. Sorry, there was a little tiny ding, and I thought there was a leave problem. Turns out to be fine. Okay, now I put work in brackets. What does work mean?
Like,
Doing something.
You've already answered it. And hands, yes, sir.
Doing something.
Doing something. And this is again the English definition. I like how this implies that physics isn't English, but it's a very specialized language. So in physics, we define the terms very precisely. In English, we don't define anything. A dictionary is not a definition. If you're arguing with someone and you go, well, the dictionary said, you're wrong. Because how are English words defined?
By how people say them in
Well,
the culture.
Yeah, it's just how people use them. So if the dictionary says a definition, but nobody uses it, that's not the definition, and they will eventually put archaic beside it if it's a very thorough dictionary, or remove that definition entirely. So English is defined by common use. If you as the youths decide to take a word and make it mean something else, like the youths have been doing for centuries, then it means that. Because like, oh, I'm sick, versus that's so sick, man. People change the name and things, and then it just means the other thing. Or what was the one I used the other day? That's not very Sigma Ohio of them. I have no idea what that means, but I like the sound of it. Okay, in physics, it has a very specific meaning. So it is the amount, and it has the same units as energy. So work isn't just like potential energy, it is energy that you've used for a purpose, but I'm not going to tell you the definition because we're not going to do that. You're not allowed to know. It's physics 11. I'm just going to tell you there's a definition, and then you get not to find out. Science is about gatekeeping. You may have heard we want everybody to know. If we did, would we make up that many definitions? No, we would not. Does anybody remember? Well, let's first draw the example. We're going to draw this. So a stretched bow. So we need a bow. If you want to make it a bow, you just have to put like handles. And look, now it's a bow. And then we want an arrow. So it's got to look taut because we're going to have an arrow on it. And then notches. And then put an arrowhead on it. And then excellent. Everybody's drawing. And we're going to say that there are 100 what? What is the unit for energy? Yes? No. Hold it. Did you not hear what I said? Because you said watt. What?
What?
What? Sorry. Bad joke. Watts is a unit of power.
Joule.
Joule. You did hold it. You called out. Can't call you. Who called out? Where was that? Was that Jojo? Jojo.
No.
Hand.
I didn't
Hand.
know.
So I need a hand to tell me what it is now. Yes, Zach.
Joule.
You throw your voice very well. So it's 100 joules. And I don't, when we use joules, students are like, oh, we have a different unit for that, and we have a different unit for this, and they just magically become that. And they don't. And I really hate that when students learn that because it doesn't help you later on. I want you to know what joules are. So, I'm going to show you what it is. We're going to do some more writing there. How much time we got? 51. I'll show you first. Leave room, but I'm going to put here energy is equal to mgh. What does M stand for? Not meters. So often the symbols in a formula, they don't actually stand for the unit. So the unit of height is meters. Or M. And G, does anybody know what G is?
Energy.
Hmm? Not energy.
Gravity?
Mass.
Sorry?
Mass.
Mass. What are the units of mass?
Kilograms.
Kilograms. Oh, I just accepted without hands again. You'd think grams, but not, because everybody looked at grams and went, those are way too small. I just literally just decided to go with kilograms. And then G is
Gravity?
gravity. Did anybody know the speed, the acceleration due to gravity on planet Earth? Yeah? No?
I've learned every way.
That's okay.
Just grab it for like a minute.
Sure.
Sorry, folks.
I'll take care of the process. Two questions.
Yellow, bro.
What's acceleration?
It's like faster running too fast.
What are those? Like how fast you get done? What are those three
You, hey, give me my laptop back. Give me my laptop. No. Give me my laptop back. Give me
Well, if I'm a physics one like this, and I'm certain thing
my laptop.
Like space. Like space, but
Give me
push
my
it, like
laptop.
jump off the space station in space and never stop moving. Unless
this is
it's
like
like
a subject I do on this.
acting on my.
Give me my laptop. Go.
What can you?
What? Hold it. No. Where are you going? You leave at 1. It's not 1 yet. We have 6 more minutes.
I know my.
Like your bus leaves at 1?
No, my uncle will come pick me up.
Oh, like he has a car?
Yeah.
Yeah, so 1
Bro.
o'clock. You're good. You're good.
Bro.
Yeah, it's not a van. Good. Okay. Last 4 minutes, because then everybody's done. Put that down. What are you doing?
You gave me correction.
Nope.
Fuck.
9.80 meters per second squared. That is the acceleration due to gravity. It's a form of acceleration. And just to belabor the point, 1 second, 2 seconds, 3 seconds, 4 seconds. At 1 second, once you've traveled 1 meter, so it is 9.80 meters per second squared. So 1 second, you're going 9.80 meters per second. How fast are you going at 2 seconds? Yes?
4 times. Oh, sorry. 9.80 times meters divided by.
No, I just wanted the number.
For 2 seconds.
Yeah, for 2 seconds. How fast are you going?
19.6.
19.6. How fast are we going at 3 seconds?
29.2.
And at 4 seconds?
39.2. Right?
Uh,
No. No.
Oh, I think this one's 0.4.
Oh, yeah. Oh, yeah, 0.4.
And I think,
29.6, right? No.
I think that's 29.4, is it not?
That's 38.2 after. Yes, it's 29.4.
Yeah, and this is 38.2? Yeah. Okay. 39, right.
Yeah.
Yeah.
I said the first one was 29.2.
No, what was the?
It is 39.
Okay.
My uncle's
I know. You're in class. You got 3 minutes. You're good. I'm sure he can wait 3 minutes.
Sure.
Are you running to a plane?
No.
Oh, you're good.
Catching a
Yeah, catching a ferry.
Which ferry?
The 1 p.m. one. Oh, sorry, the 2
Yeah, you missed that. The 2 p.m.?
Yeah.
Okay, run. You're going to be late. You might miss it. You should have left earlier. I don't know why you're still here.
Can I go?
No,
You're not catching.
you're not catching anything. And your notes should be out.
I'm also catching.
I might make the whole class wait for you to get your notes out. Okay, so acceleration, Oliver. Acceleration means that every second you were at.
Oh, look at this.
What just happened? Oh, that happened. At every second, you were adding that value onto it. So at the first second, it's 9.80 meters per second.
So it's 9.80 per second, which means 9.80, 19.6, 29.4, 39.2. So you are going faster and faster and faster at a steady rate. You can have acceleration of acceleration. So the speed at which you are getting faster also gets faster. We won't do that. But that is the first type of acceleration. The speed is just getting faster and faster. That is what happens with gravity. You drop a ball, it gets faster and faster and faster. So that's part of what gives everything energy, is because it's going faster and faster and faster. The formula, E equals mgh, is that I could then take a mass of 1 kilogram and a height is equal to 1 meter. And g, we already know, 9.80 meters per second squared. And I could go, that equals 1 kilogram times 9.80 meters per second squared times 1 meter. What's 1 times 1? 1 times 9.80? 9.80. That's the easy part. What's a kilogram times a meter over second squared?
Kilogram meter second squared.
Yeah, it's just a kilogram meter per second squared. And that's not that hard. That's like saying A times B over C squared. You've done that in math, right? Yeah, you just get ABC squared. The same thing. But then we multiply it by M. What does that do with this?
M squared.
M squared. So it's a kilogram meter squared per second squared. Right? That is what we call a joule. So saying that it's 100 joules is not a random amount. And the reason I'm doing that, and I'll let you go in a second, is because this is 1 kilogram. And I can take it, and I can put it a meter above the floor, and then if I drop it, I know it hit with 9.80 joules of force. So it's a real thing with weight and distance. And you may now pack up and go. Thank you very much. And not weight and distance, mass and distance.